Hey guys, welcome to the final video in this series. Now once again, as I've mentioned before, a lot of the stuff we've done, particularly measurement and in the content for year 9, we would have covered a couple of years ago, both in the year 7 and 8 content. So I've skipped over a lot of the regular volume questions, volumes of prisms, things like that we've already done. And I'm jumping straight into the final topic of some harder volume of cylinders questions. Now I did a video in the year 8 course in which we looked at the basic ideas of how to find the volume of cylinders and how to get to the actual formula. So I'm making this video assuming that you have watched that. So if anything here is unclear, please go back, watch that video so you get some of the intuition for how we get the main formula for the volume of a cylinder. So our volume equals pi r squared h. And so if this is unfamiliar from this video, please go back and consult that. These are just some harder, more abstract questions that you will encounter in the year 9 volume of cylinders topic. Now, what we have here, we are tasked with finding the volume of this solid. So this entire bit here, it's kind of like a cylinder that's been chopped out. And a little chunk here is missing. So this whole space here is missing. It's been cut out. Now there's a couple of ways we can work through questions like this. So I'm going to go through one way for me that makes sense, but we'll also go through the other way we could have approached this. So one thing we notice is that this is a 90-degree angle. So what's going to be the angle of this entire revolution? Well, an entire revolution is 360 degrees. So 90 less than that, to find this angle, that would be 270 degrees. Now, once we get here, there's a couple of ways we can do this. Now, if we remember our volume formula, that is taken from the cross-sectional area of our circle multiplied by the dimension that is going away from that cross section. So that third dimension, that breadth, and that in our case is the height. So if we think of this, what is our cross section? Well, our cross section is this. It is 3/4 of a circle, because if I break this up, I have 1/4 up the top, another quarter down here, a third quarter, and my quarter up here, which is missing. So this is my cross-sectional area. My cross-sectional area is 3/4 of a circle. Or if we use our cross-sectional area formula for the areas of a sector, if you remember, so that would be, for example, 270 degrees over 360 degrees. So that would be 270 over 360, which is eventually going to simplify, if we simplify this fraction, to 3/4 of a circle. Another way we can think about this is 4/4, 4 out of 4, 1, our whole is here, and we are subtracting 1/4 from that. So we get left with 3/4, or we're subtracting 90 over 360, which simplifies to a quarter anyway. So our cross-sectional area is 3/4 of a circle. So that area, A, is going to be 3/4 times pi r squared, because I have my whole here, and I have my portion of the whole here. because this is a sector. The cross section here is actually a sector. It's not a full circle. It's a chunk taken out of a full circle. So in doing this, we want to first label, what's our radius going to be? Well, that is this length here. It's stretching from the middle out to the edge. So our radius here is 2 centimeters. So what we're going to do is to find our cross-sectional area, we're going to do 3/4 times pi times 2 squared. Now 2 squared is 4. So once we simplify this, the 4 here is going to cancel with the 4 here. We have 3 divided by 4 multiplied by pi multiplied by 4. 3/4 of 4 is going to be 3. So we can cancel those out here, and we get left with 3 pi as the cross-sectional area. Now, looking at the next bit. So here we have found my cross-sectional area. That's 3 pi centimeters squared. And now to find the volume, we just want to multiply that by the height. So if we put this cross-section face, if we put that on the ground, the height would be the side going away from it. So that'll be this one here, and this one, and this one. They are all the same length of 5 centimeters. So what I'm going to do, because my volume equals the cross-sectional area times my height, I can just substitute in my values. My cross-sectional area is 3 pi, and my height is 5 centimeters. So I can substitute these values in. So that's going to be 3 pi multiplied by 5, and that gives me 15 pi centimeters. And remember here, we're looking for volume. We're looking at 3 dimensions. So we put cubed up here as my unit. Now I've left this in exact values because I don't have my calculator on me. But if you would like to, for practice, you can pop this into your calculator and answer this correct to 2 decimal places if you would like. But the answer and how you write it doesn't really matter. What I'm trying to get at is how we can approach some of these harder, more abstract volume of a cylinder questions. We're still doing the same thing. We're still finding volume as the cross-sectional area times the height, but the cross-sectional area here is not a perfect whole circle. In this case, it was 3/4 of a circle. Now, let's look at our last question for today. And like I said, I've done a video on this previously, so please consult that if you need some extra practice for some simpler questions. This video should be treated as if you've done a lot of these questions, you're quite familiar, and you want to know what are some more abstract questions that come out of this. So, what I have here is I don't necessarily have a cylinder, but I can see cylindrical elements here. This is an example of, if any of you have skated, this kind of looks like a half pipe. So if you're standing here with your skateboard, you can go down and then, make your way up, back and forth. But that doesn't really matter. But this is an example of where you may see this in day-to-day life, this type of shape. Now, say we wanted to find the volume of this. Well, let's just consider the shapes that we can see here. If I look at this outline, so if I drew, for example, this, I connected this here, I connected this here, you would see I have a rectangular prism. If this was the whole thing, for example, you can see here, this makes a rectangular prism. However, something has been cut out of this. So I have my rectangular prism, but What's missing in here is a half cylinder that's been cut out. Do you kind of see that here? We have a half cylinder that's been cut directly out of this rectangular prism. So to find the entire volume, I'm going to have to consider, to find the remaining volume here contained inside this actual shape, what I'm going to do is I want to first find the volume. So the volume of this shape is going to be the volume of the rectangular prism minus the volume of the half cylinder. The half, cylinder here. So, in order to find this, we need to find two separate volumes. So let's find this one first, the rectangular prism. Well, this is fairly simple enough. This is some revision for volume. If we want to find the volume of a shape, especially a rectangular prism, we can find any cross section here because they're all rectangles, and we want to multiply this by the length or the dimension going away from that. So what I'm going to do is I'm going to find this first area. So this guy here, my rectangular prism, that's going to be my 10 by 20 here. So that's going to be 10 by 20 by another 20 here. Another 20 there. So from there, I'm going to subtract the volume of my half cylinder. So what's the cross section of this first? Well, that is a half circle whose diameter, so stretching from this edge to this edge, is 20 centimeters, and whose height is 20 centimeters also. We can see this length going away from the cross section is the same as this length down here of 20 centimeters. So let's just lay out the working here. So I'm going to subtract first my cross-sectional area. Now, what's my cross-sectional area? Well, let's do this like this. My cross-sectional area is going to be half the area of a full circle here. So my circle here, its area is going to be pi times r squared, and my radius is 20. So, my diameter is 20, so the radius is going to be 10. So I'm going to do pi times 10 squared, but I'm taking half of that because it's a semicircle. And all of that I'm multiplying by 20. My length going away from my cross-sectional area here. So I'm doing pi times 10 squared times a half times 20. Cool. So multiplying these guys here, when I do 10 by 20 by 20, I get 4,000. So I'm going to get 4,000 here. And from that, I'm going to subtract pi. So pi times 10 squared times a half times 20. That is going to give me 1,000 pi. Because 10 squared gives me 100. Timesing 100 by half gives me 50. Multiplying that by 20 gives me 1,000. So that is my answer here. I'm leaving it in exact values because once again, I don't have a calculator, but you can leave it in exact values as well. You don't always have to leave it in decimal points. Usually questions here will specify the level of rounding they want you to do. But if you see exact values, we always want to leave things in terms of pi. And once again, I've put centimeters cubed because we are measuring a volume. So the units are all gonna be in centimeters cubed because we are looking for a volume. We are looking for 3 dimensions. But in essence, we have broken down quite a tricky abstract question into easier parts by considering what we know about the volume of cylinders from the previous video. But this is how you can use what we already know, what we learnt from last year, looking at volumes of cylinders, and applying this to some really tricky abstract questions. But thank you so much for watching, guys, and that brings us to the end of this series. So I'll see you in the next one.